I am the director of the Developmental Brain Imaging Laboratory at OHSU. And what we do in that lab is exactly what I'm going to talk to you about today, and that is study the adolescent brain. We study it for a whole bunch of reasons, many of which are probably the very reasons that you're here. Either you have an adolescent or you work with an adolescent, and you just kind of want to know what is going on in there. And that's what I'm going to try to tell you about today, with as little feedback as possible. Does this sound okay? Okay. All right. So before we get started, although it may seem somewhat obvious, I think it's important to define what adolescence is. And I think that you might actually be surprised if I asked, say, 5 of you to write down your definition of adolescence. My hunch is, and from experience I can say, we'd have 5 different definitions. People define it in various ways. And of course we know, just kind of from a broad sense, that it's the transition from childhood to adulthood. But what is that really? Many people, and I think it's still probably commonplace, think of adolescence as the teenage years. So I think that if I had to guess, maybe 3 of the 5 of you that I would have asked to write your definition down might have said, 13 to 18. How many of you would have said that as adolescents? None? Really? A couple. Okay. It does actually extend longer than that. Some people think of it as a time of sexual maturation. It's when puberty occurs, and so historically that was sort of how adolescence was defined. But what we do know is that it's really a period of time, and it's a rather long period of time, that's marked by a whole host of changes. And these include biological changes, puberty, as I mentioned, physical changes, so the body's changing in concert with puberty, social changes, cognitive changes. And the key thing that you're going to learn about tonight is that these changes aren't all happening at the same time. They're not all happening on the same trajectory. And so what that results in are some periods of kind of difference for the adolescent time period. So why do we study adolescents in particular? And why not just lump them with children or lump them with adults? Why is it its own unique period? And what we do know from, I would say, about the past 15 years of research is that while we used to conceptualize adolescents as adults or children, making a break point around maybe 16, we know now that those models don't hold. So adolescence is its own period of time. All bets are off. It's very different from childhood and very different from adulthood. It's also a time when we see a wide increase, or a large increase, in vulnerability. And that vulnerability is partly explained by some of the differences in biology and differences in the trajectories of development that I'm going to talk about tonight. But because of that vulnerability, we see the emergence of a whole host of different types of mental health disorders during adolescence. So we see the onset of depression significantly rise during the teen years. There I'm going to use teen interchangeably with adolescence. We also see the emergence of other types of behavioral disorders, so some of which may seem voluntary, like the initiation of drugs or alcohol, and some that may not be. And we do believe that this is partly a function of the state of development of the brain. It's actually been just in recent years that folks have reconceptualized adolescence as a really critical period for brain development. So we think about early childhood, even prenatal development, as some of these really critical times for the brain to mature. You know, cells are developing, they're migrating. It's very sensitive to experience. We all know things like prenatal alcohol exposure can cause dramatic negative effects on development. Many of you may know that even other types of prenatal exposure, stress, things like that can alter development. But adolescence, okay, it's back. I don't know. Adolescence is also a critical period of time like that. I might be out of batteries. Wait, can you hear me anyway? Okay, as long as my voice stays, hopefully you'll be able to hear me. So it's also a time of development that's very much like some of those prenatal years, where we think that it's really sensitive to a lot of the perturbations or experiences that an individual may or may not have. And I think one of the things over the last 15 years that has allowed us to explore this in so much more detail
that we have really sophisticated methods now for studying the adolescent brain. So we can look with techniques like magnetic resonance imaging that are not invasive in any way, and it allows us sort of a window into the adolescent brain. Never before were we able to do those sorts of things, and so we know now much, much more about the adolescent brain than, say, was known 20 years ago. So, because I'm an optimist this way, we're going to start with the positive. We're going to talk about some of the positive changes that occur across the adolescent years. Thinking about it in terms of a period of opportunity, some of the improvements in functioning that we see. So there are a lot of changes that happen to cognition or thinking behaviors that occur across the adolescent years. And as I'm talking about those various changes, I want you to think of them as sort of a slow process, meaning that you're not going to see a large difference between, say, a 12-year-old and a 13-year-old per se, but if you looked at a 12-year-old versus an 18-year-old, you'd probably see some marked difference. So across adolescence, again, over this long, protracted course of development, teens tend to get better at a bunch of things. One of the things that they get better at doing is problem solving. So the ability to just kind of approach a problem, formulate a plan about that problem, figure out how to attack it, and maybe some different ways of attacking it. They get better at multitasking. Now this sounds trivial, but multitasking, as all of you know, is a critical part of our day-to-day lives. We do it all the time without even thinking about it most of the time. Multitasking is something that we use whether it's driving to work in the morning, driving here, you're telling your child in the backseat not to kick the seat, or you're turning on the radio, or you're thinking about what you were going to make for dinner tomorrow. That's multitasking. Teens can do this, and kids can do this, but this is something that gets monumentally better as teens get older. Has real ramifications for some of the demands that we place on teenagers, especially when we're thinking about multiple different course demands, so lots of different classes, changing demands there. Driving, the fact that somebody's actually going to sit in the car, let alone listen to music and sit in the car, let alone hear somebody talk to them while driving and listening to music. This is all very, very relevant to the multitasking that is not yet mature, particularly in early adolescence, and is getting better across this time. Inhibition and judgment, so the ability to stop yourself from doing a more automatic response. Now, admittedly, adults vary in their ability to do this too, but it certainly is what differentiates the young child who walks in and does not have any qualms about telling you that your breath stinks from the teenager that might think, wow, the breath stinks, but I'm going to hold that thought to myself. Versus the adult that never learns that skill. So it all happens. There's definitely a trajectory here. But certainly as adolescents develop, their ability to stop themselves from doing something more impulsive or something that's just more salient to them gets better. So along with that ability to sort of stop oneself comes just overall better emotional and cognitive control. So the ability to control the brain, the ability to regulate our thinking, so that's kind of that stopping ourselves from thinking or saying something. The ability to control our emotions, and this is going to come in very relevant in a little while. So the ability to say, I'm feeling this emotion, what do I do with it? How do I regulate it? How do I maybe calm it down? How do I maybe ramp it up? There's some control there that develops across adolescence and is not mature in the young, sort of early pubertal youth. So accuracy and speed of responding. This one doesn't sound all that exciting, but accuracy and speed affect just about everything we do. And so most studies, almost irrelevant of the type of function that an individual is doing, if we look at an adolescent, say at 12 versus 18, we see much faster responding as they get older, as well as more accurate responding. The brain is getting more efficient, and I'm going to talk about the underlying neurobiology of that in a second. Planning and understanding long-term consequences. This is something that I think is a hard one to get our heads around as adults. Why, oh why, can the 13-year-old not always understand how what they're doing today affects them 10 years from now? Why do they not care all the time about that? And that's just simply because this function is underdeveloped in the early adolescent years, and it continues to develop as they mature. Social awareness and perspective taking. So this is one that by all means, in addition to all of these functions, people have this capacity at an early age. People can do all of these things at early childhood.
But it gets better as they get older. Thank you. It helps to not try to scream. I might retain my voice now. So the ability to just kind of step into somebody else's shoes. Again, kids can do this. Kids can have empathy. They understand. But the ability to do that in a nuanced way that perhaps we as adults can do is something that is not mature early in adolescence and continues to get better as kids get older. So I always give this slide a little bit early when I give talks like this, mostly because I think that it gives you an idea of some of the hard tasks that we put kids through to see how their brains are developing. This is a task called the Paced Auditory Serial Addition task, and I often make an audience member participate, but I might spare you since it's after 7 at night. My rules are not before 7 in the morning and maybe not after 7. At any rate, what we do with this task is we ask an individual to listen to numbers that are presented on a tape recorder. And all your job is to add the number you hear to the last number you heard. And they're only single-digit numbers, so shouldn't be that difficult of a task. So if I were to say 1 and 3, right. And then if I said 2, you guys are on it. Love it. So the challenge there, and you may or may not have picked up on it, is that yes, the last number you heard before I said 2 was 3. But when you added, oh, now I can't even keep track. See, this is what happens when it's late. I said 1 and 2, 1 and 3, and you said 4, and then I said 2, and you said 5. Do you see how you're adding the number you heard to the last number you heard, and you're inhibiting the response that you gave? Wow, it's late. So I will probably not do so well on this right now. And as you can see, our younger kids, those that are around the 10, 11-year-old age range, they're not doing as well on this either, as we see some of our 16-year-olds who approach 90%, 100% accuracy. So what we can see is that as kids get older, even something as simple as adding just single-digit numbers, these never exceed single digits. So it's not an arithmetic thing. Most 10-year-olds can add single-digit numbers with pretty good proficiency. But the ability to inhibit that response, the ability to ignore what you just said in favor of remembering what you heard before, gets a lot better. And it just kind of is a task that really, I think, nicely exemplifies that. This is a graph from a, oh my goodness, I'm so sorry, from a study not too long ago, looking at some of those functions that I also described as changing across adolescence. And what we can see here is not only do we see change in some of these behaviors. Here we're looking on the lightly dotted line, sort of in the middle, we're looking at the ability to plan ahead, planning. The more larger hashed line is looking at the anticipation of consequences. So again, this is sort of appreciating that what we do now is going to affect us, maybe tomorrow, maybe next year, maybe 10 years from now. And then the other one is time perspective, so just understanding, again, how things lay out across time, so the perspective of things not all happening at the same time. And what you can see is that while time perspective shows a pretty steady increase across adolescence, we actually see a dip around puberty in the ability to anticipate consequences and plan ahead. It gets better across adolescence, and if we look at the 10-year-old compared to the mid-20-year-old, by and large they're doing better at those things, but there's this little dip. That little dip is going to be described a little bit later. It's related to some of the pubertal processes that happen and some of the derailment that kind of happens in the adolescent brain. So keep that in mind. So there are lots and lots of behavioral changes that are happening. We talked about changes in problem solving and in regulating ourselves, planning, perspective taking, all those things that are happening behaviorally. But what's happening underneath all of that to support these changes that are admittedly quite positive? So the brain structure that during adolescence is changing pretty rapidly. Believe it or not, but past the age of 6, overall brain size doesn't change that much. And I always think this is kind of funny, having a 5-year-old myself, thinking these little kids walking around with these kind of big heads. They look a little bit like bobbleheads sometimes when they're early on. Well, their brain is pretty much fully grown at a pretty early age. And so we see a bunch of changes, but they don't result in an overall net size change too much. About a 5% change. But what we do see to keep it from being an overall net change is some things are getting bigger and some things are getting smaller. So the white matter, you can see the little arrow there pointing to all the white in the brain. This is basically the information highway of the brain. These are the axons that connect the neurons, which are the cells that do the talking in the brain. And those axons are getting covered with a fatty sheath called myelin, which is essentially like insulation on a wire. It allows for much more efficient transmission of information from, say, the front of the brain to the back of the brain. The other thing that's happening is the gray matter, which you'll see both all the way around the brain as well as in some of the spots internally in the brain. Those are the neurons. So those are the cells that are doing the talking. What happens really early in life is there are tons and tons of connections made between these cells. Some of them are experience dependent, and some of them just happen programmatically as a function of us just blossoming into people. Those connections, all the hundreds and thousands of them, are really not that efficient, to be honest. It's kind of the analogy of using the whole kitchen sink to do a given problem. What we see across adolescence and what we see as a function of the experiences that individuals have really across the lifespan is a selective kind of pruning off of those connections. So the ones that are needed and really are necessary for a given task are going to be strengthened and kept, and those that are just kind of the extra tools in the kitchen sink are going to be pruned off. And what this does is it makes it a much more efficient system, so that increases in processing speed or speed of doing tasks or the accuracy with which an individual does a task, those all are going to become more efficient because you're selectively using the tools you need to get the task done. The front part of the brain, so this is a picture of the brain, kind of an aerial view looking down, where the sides would be the ears and the front would be the forehead. This is the frontal lobe of the brain, and this is the part of the brain that undermine, in adolescence it sort of does undermine, but underlies all of those functional changes that I was describing. So it's the part of the brain that allows us to inhibit ourselves, to stop us from telling somebody that their breath stinks. It's the part of the brain that allows us to plan. It's the part of the brain that allows us to multitask. And it happens to be the part of the brain that develops last. So we're looking at development across the lifespan. We're going to see that this part is going to be the part that's the latest to have the white matter really become efficient, and the latest to have all those extra connections prune off. What that means during the adolescent period is that it's sensitive to the experiences that an individual has. It's still actively making these decisions about, is this connection necessary or should I get rid of it? That's experience dependent. So providing adolescents with the correct experiences and positive experiences to shape their brain development is of crucial importance, and I'll come back to that in a bit. This is a fancy slide. I'm not going to tell you much about it from sort of a technical standpoint, other than to say this is that white matter in the brain. It's a really fancy imaging technique we use. What I want to show you is the thickness of the pathways is essentially what it is. Those pathways that allow point A to communicate with point B, but here in the back of the brain. You can see that at 5 and 6 years in these males and females, their connections are there. So these are just different pathways in the brain. But when we look to the older male and then the older age ranges and then into the adulthood, what we see is the thickness of those pathways. That thickness being that myelination or that insulation that provides us efficiency becomes greater and greater. And there's been a number of studies that suggest that this actually does happen into the mid-20s. So a lot of people have probably heard the statement, oh, the brain isn't done developing until you're in your 20s. Everybody heard that? It's kind of, believe it or not, 10 years ago, nobody even knew that. But now we know that. We know that the brain's not fully developed. And there are some studies that would suggest that it might not even be developed until you're 30. But this is an example of that. So there are lots of structural changes happening in the brain. Again, there's some pruning of excess connections that are just making it kind of an inefficient system. There's some insulation that's occurring in the information highways of the brain that are allowing this part to talk to this part in a very efficient manner. There are also functional changes that are happening within the brain cells themselves and the way that the brain is organized. And again, some of the techniques that we use to study the brain, to non-invasively study the brain, have told us this over the last few years. So brain functioning, what we see when we look at adolescents is that the areas of the brain that are developing, so the front part of their brain, have to work really hard to do some of these tasks that I was describing. So So if you look at an adolescent trying to multitask, and we look at what's happening in their brain while they're doing that, they're using those front parts of their brain a whole lot more than, say, the 40-year-old that's doing the very same thing. Now, what's really interesting is sometimes they can do it just as well, especially if it's not really hard. But they're having to work so much harder to do that. What happens when somebody has to work a lot harder to do something at a comparable level to an adult is that it's vulnerable. It means that any little kick to that system is going to make it so that they can't work that hard. Any little perturbation, right? So you imagine somebody who's lifting weights, the analogy being somebody who's really good at lifting 100 pounds. And then you maybe have a 7-year-old boy that's trying to lift 100 pounds. 7-year-old boy could have a cough and drop that 100 pounds. I mean, there's so many little things that could just tip the scale. That's what's happening here at an adolescent level. So the brain, although they can do some of these things, it's vulnerable because they're really tapping it out in order to do it. The other thing that we see across some of these imaging studies is that we do see some evidence for efficiency. So if we look at, say, early adolescence and mid-adolescence and then adulthood, we can see sort of this rise in the areas that we see developing. So maybe the front part of the brain is being used more at 15 than it was at 12. But then we'll see it maybe at 18 as it comes down again. And we see this efficiency that's happening. They're not having to work quite as hard. And it kind of supporting the idea that adolescents tend to maybe use some different strategies than, say, kids. We see different parts of the brains active. So when they're doing a task, they may use a more sophisticated strategy. Maybe they'll use a verbal rehearsal strategy to remember something visual. Now, if we think about trying to remember something visual, you guys can maybe remember, if you're trying to remember some directions somewhere. Sometimes what we do in our brains is we make a verbal rehearsal for ourselves to really make it more salient. So teens will do this too, and they learn how to really encode information in their brain in a way that allows them to remember it better and makes a richer representation. And we see evidence for this at the brain. So, I just talked about all the good things that are happening. So, behavior is getting better. They're getting more able to regulate themselves. They can plan, they can appreciate, they can perspective take. Again, not overnight. It's a long course of when these functions come on board. The brain is becoming more efficient. It's becoming more selective in how it picks its tools to do things. So if all of these positive things are happening, why do we see depression raised tenfold in adolescent females? Why do we see substance use happen? Why do we often feel perplexed by the behavior that we see in adolescents, just thinking to ourselves, really? Why'd you make that decision? I mean, why? If it's all getting better, why are we so dumbfounded? There are reasons. One of those reasons happens to be that the brain is just, again, it's changing, it's dynamic, sometimes it's tapped out. And life is changing. The things that we ask kids to do, the experiences that they have on a day-to-day basis are dramatically changing. Of course, this is not a real representation of the adolescent brain. Some of you may argue that perhaps it is, but I like to use it just to kind of exemplify what we often are confronted with. So, when I talked about behavior earlier, I talked about some of the more cognitive changes that adolescents experience. So the idea that their thinking is better. Well, thinking is only one part of behavior. There's also feeling. And that's a crucial thing that is changing during adolescence, how they feel. And it was touched upon during the prayer. I'm going to touch upon it a bit more. So one of the things that happens experientially during adolescence is there's a real pull away from the family of origin and a movement towards peers. That's actually an adaptive process. It's part of the way that the world works, that we want our kids to move out of family of origin eventually. And we want them to make, to form partnerships and to make friendships and to marry and procreate. And these are things that are adaptive in our society. This starts to happen around adolescence. There's also a whole host of new demands. I talked about going from, say, elementary school to middle school to high school, where the number of classes or the number of classrooms an individual might be in just monumentally increases. The demands that are placed on teens. So perhaps it's extracurricular activities. Perhaps they start to work. Perhaps they take on more responsibility at home, or the demands that are placed on them are more significant at home. These are all things that are quite substantial during this time. The other thing that happens really early in puberty, and this kind of goes back to my original asking you to think about what adolescence is in your mind, are the pubertal changes that happen. So these happen in contrast to some of the cognitive changes that I described that take a long time to happen. These happen pretty fast. When hormones kick on, all bets are off again. And this happens really early, and it happens very quickly. And it carries with it a whole host of different things, including changes in emotion and motivation and behavior. So puberty happens very young. It's actually happening younger and younger in Western cultures than ever before. And so many females, when we're thinking about puberty, are starting this process at 10. Males are usually a year or two behind. But we're talking about anything from 9 to 11 to 12 when all of this stuff is starting. So when you think about the brain, and maybe the white matter or the highway of the brain not being mature well into your 20s, and you think about this stuff turning on at 12, you can understand why there's this long period of vulnerability. One of the key things that I think heightens this vulnerability is the emotional responsiveness of the adolescent brain. Now, all of you have been, except for the little ones that may have disappeared, there's still a few, most of you have been an adolescent. So you can at least, the very least, remember back. I'm guessing many of you have adolescents or work with adolescents. And I would think that even sometimes as we reflect back upon our own childhood, and I think there's probably very few of you that would say, I would love to go back to 15. That was an awesome time. No, I wouldn't. And I don't know many people that would. But you still have a hard time. You know you don't really want to go back there. It was a little rough. But it's actually hard to go back and remember how rough it is. Probably adaptively so. So adolescence is a time of increased emotional intensity. Probably not that shocking to all of you. But what's really interesting about that is that it is not just that if you ask an adolescent, hey, how was this experience for you? And they say, oh my goodness, this was the worst day of my entire life. So-and-so wouldn't talk to me, or I failed a test, or something that we can, as adults, often say, yeah, I know that had to be rough, but it's going to be okay. They're going to probably talk to you tomorrow, and that was just a quiz. I'm sure you'll do fine on the next one. Or I know that you tripped in the hall, and so-and-so saw you, and heaven forbid, that just ruined your entire social career for the year. I mean, these are the things that they perceive and the real salience that they put to them. That is not an adolescent being dramatic. If there's one thing that you take with you tonight, I want you to look at these adolescents that you work with in a different way and think to yourself, they're not just blowing this out of proportion. This is not just for my own sort of dramatic audience right now. What's happening for them is that their brain is perceiving the same event that maybe you or I, or even the child in the room might perceive very differently. The part of the brain that helps to process emotional information is the amygdala. It's deep in the brain, kind of down behind the ears. And what we see is that if we present adults and adolescents with the exact same stimuli, the exact same neutral stimuli, maybe it's a picture of a chair, the exact same negative stimuli, maybe it's somebody hysterically crying or injured or in pain. Admittedly, some negative salience there. When we look to see what happens in the brain of the adolescent versus the adult, the amygdala, which is again responsible for this perception of emotion, and in particular negative emotion, shows way more activity in adolescence. Same thing happens if we look at other physiological measures of stress. So if we were to take their heart rate or look at galvanic skin response, showing them the same kind of stressful experience, their bodies are going to perceive it as far more stressful. Their heart rates are going to go up way more than the 5-year-old or the 30-year-old. They're going to sweat. They're going to show all this physiological response to stress that tells me and tells you that this isn't just them being dramatic. This is not, their own sort of mysterious way of interpreting the world. This is how their body is interpreting the event. Different than other periods of life. What's interesting about this is that when we look at how the brain processes emotional information, we know that a lot of that response is tied to some of the pubertal hormones that change. Now remember, those change when? Early, right? Puberty is early, maybe 10, maybe 11, maybe 12. So this stuff is turning on really early. And when does the problem solving mature, or the ability to regulate yourself mature? What did I say about that? Yeah, it takes time, right? It happens across adolescence. So you can see a little bit of a problem here. Emotions are going rising high. They're really crazy emotions. They're more salient than any other time of life, hands down. There's more stress, right? Demands are changing. Everything's kind of going haywire. And the brain's ability to regulate that, or to plan, or to problem solve, or to perspective take, it's just not there yet. This is that vulnerability that we're describing. It's interesting to me because I think that, again, we often don't appreciate it when we think about teens. We hear them as dramatic a lot of times. Any of you ever thought your teenager was dramatic? Again, try reconceptualizing it in your brain. When you see that and you start to feel, oh, this is really dramatic, I want you to think to yourself, wow, their amygdala is firing like crazy. This is not their fault. This is not just for my benefit. This is their amygdala. Think of it. It will help you. And what it will help you do is it will help you have empathy. Empathy goes a very, very long way in working with adolescents. And when I say empathy, I don't want you to confuse that with, gosh, I understand what you're feeling. Because no teenager ever, ever, ever wants to hear that, I will tell you. No. It is very different to say, wow, this must be really hard for you. This must be really stressful. I can see that this is really upsetting. Those types of comments, they go a long way. When I work in my clinic, I'm a pediatric neuropsychologist, so I see kids that have a variety of different things going on, everything from maybe some mental health issues, to learning disabilities, to some kind of an injury that they've had to their brain. And I often talk about adolescents just in general to the parents that I see. And one of the things that I talk about is the fact that as adults, we often can go on autopilot. So for those of you who work and maybe drove to work this morning, anybody get to work and think, wow, I don't even really remember driving here. I just kind of did it. I know I do that all the time. Granted, it's only 5 minutes. I'm not a danger to others around me, I promise you. But we do it all the time. So much of our lives is so routine that we can do it on autopilot. Well, when you think back to all of the changes that I was describing in adolescence, the social changes, the environmental changes, the classroom changes, the brain changes, there's no autopilot. You throw a wrench in that, and again, the system breaks down. We're talking about the 7-year-old holding 100 pounds, that if a feather tickles him in the armpit, it's going down. This is the same thing. It's this vulnerable system. They're working really hard. Maybe they're holding it together. A little tip to that scale could make a difference. So one of the other things that we see is that adolescents tend to make riskier decisions than adults. Now this is not, by no means are any of the things that I'm saying sort of all or none. There's a whole wide range of variability in humans in general. And so there's some risk-taking people and people who are more risk-averse. That's true for kids, it's true for adults, and it's true for adolescents. But by and large, when we look at adolescence as a developmental period, we see that they tend to make more risky choices. So here, what you can see on the left side of the screen is basically the number of times, or the percentage of times that an individual would take odds of 30 to 70. So this isn't even 50-50 odds. This is, you got a 30% chance of winning, 70% chance of losing. Good odds? Maybe not. Maybe not the best odds. They're not even 50-50. We're not talking about 70-30 here, folks. What you can see is this 10-year-old, this poor little kid over here, 75, maybe 100% of the time, they're going to take those odds. Why not? 30%? It's good enough. Whereas you look at this very smart, staunch 35-year-old who's making that choice never. Never going to take those 30% odds. Maybe the 30-year-old, they're going to take it about 25% of the time. Maybe they're going to roll the dice a little bit. But what we see in general, and this is just again to kind of give an example, is that this type of risk-taking behavior declines after adolescence. It rises during adolescence. In some ways it's adaptive. You've got to go out and take risks. You've got to try new things to make some of those adaptive changes that we were describing. Maybe not as many as they often take, but it is something that we see as a phenomenon during adolescence. What I think is interesting is that there are lots of things that change risk-taking behavior, and there's lots of things that change emotional behavior, and I'll talk about that a little bit more in a second. But this is a study that came out a couple of years ago, and this is a typical example of a study that we can do in the scanner, so while we're taking pictures of somebody's brain. And I like this one because it actually has some real lifeness to it. And essentially what the person sees, and it's a little bit hard to tell here, and I apologize for not having a pointer, is it's basically a driving simulation task given to adolescents. So you see yourself at the driver's wheel, at the wheel of the car, and then every once in a while you're going to get a yellow light. Now you're trying to get through this, you're told that you want to get through this course as safely but as quickly as you can. So that you want to go kind of fast. You don't want to take your time. You're going to be rewarded for getting through it safely and quickly. So when the yellow lights come, you have a decision to either stop and have a 3-second delay, or you can choose to accelerate and go through the yellow light. Sometimes that will just mean you get to go through the yellow light, and sometimes it means that you're going to get hit. So the risk that happens when you run a yellow light. What we see here is that when we look at adolescents, adolescents versus young adults and older adults, if we look at the percentage of risky decisions they make, so the times that they decide to accelerate, we see that adolescents, young adults, and older adults, when they're alone, that's in the blue, they make about a comparable number of decisions here, actually, in the driving decisions. Young adults tend to make a little bit more risky decisions. What's remarkable is the red bar. The red bar is when there is a peer. So you got a friend watching you do this. This is your buddy Joe in the car next to you, or in the seat next to you, when you're choosing whether to run the yellow light. Look what the adolescents do. They start running those yellow lights like crazy. This is real. This is actually legitimate. They bring a friend with them to do studies, and this friend hangs out, and then they complete this either alone or with a peer, and they balance it so that not one condition was first. So some kids will go with the peer first, some are with alone first, and so it's all balanced and it all jives. But adolescents tend to make way more risky decisions when the peer is present. Same thing happens with the number of crashes, which is a function of the number of risky choices. What's interesting, even more so, is that when we look at in their brains, what's happening when they make these risky choices, the part of the brain that responds when we have reward, which is the same part that is in kids and adults, it's called the Nucleus Accumbens. It's the reward sort of response center of the brain. It actually activates when they take risky choices, when they make a risky choice. So they're feeling rewarded with the peers. When their peer's there and they say, I'm running this yellow light, whoop, ding, 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 their brains go crazy with reward. Because they actually are perceiving this as a very, very valuable thing. All right, so to summarize this part a little bit, what I will say is that we have reward systems in the brain, emotion systems. They're deep in the sort of the bottom part of the brain. They are triggered with puberty and hormonal changes, which start really young, younger than you think, really, really young. So when you think about puberty, a lot of people will think about girls achieving puberty, think about menstruation. Menstruation is the end of puberty. They're through most of the pubertal changes. They happen way younger than that. Boys, way younger. When the voice starts to change, that's not the beginning of puberty. That's later in puberty. So this is happening very, very early. What's happening across adolescence with age and continued experience and continued maturation of the brain is the ability to regulate and to use judgment and to reason. This little dotted line, the white line that came in there, that's that information highway that I told you about that gets insulated as people get older, well into your 20s. So what that does is it allows the regulatory and the judgment and the reasoning parts of the brain to interact with the reward and the emotion parts of the brain. It allows it to say, hey you, that emotion that you're feeling, let's turn it down a little bit. Or hey you, that reward that you just felt by running the yellow light with your friend here in the car, maybe not the best thing. Let's maybe not make that decision even though it felt good. Let's reason through this a little bit. And that's what happens as kids mature, but it is not happening at 13. There's your vulnerability. And the longer the period between puberty and when all this stuff sort of turns on, and the fact that these other functions are developing, the longer that is, the longer a period of developmental vulnerability there is. So, what we see then from adolescent behavior is that they tend, at least at face value, to use more emotion and reward-based parts of their brain to make decisions. It just kind of drives them. It's sort of like you think about little kids that don't have to reason through things. It's a little bit different, right? But it's still kind of the same. Those parts of the brain are kind of driving the bus. Now, invariably, and I bet if I took a vote, I bet there's some of you thinking this right now, parents will think to themselves, this does not apply to my teenager. My teenager can reason through all sorts of things. They know right from wrong, they know what their consequences, they know that if they drive through a yellow light, they could get killed. They know not to, all sorts of things. They know not to use drugs, they know not to do all of these things that we think are horribly egregious that teenagers do. Well, you're right, they do know that. They do know that. And what I will argue is that when you're sitting at the dining room table and you're having a discussion about, hey, what would you do if so-and-so offered you drugs? Hey, what would you do if you were in your car with your friend and they were like, oh, run the red light, do it, do it. What would you do? And many of you who have lovely, responsible teenagers would say, oh gosh, Mom or Dad, I would not do that. I know better, I know what the consequences might be, this is how I would avoid it. And those are good things, don't get me wrong. I'm not discounting all the lovely adolescents that have come from this room. But what I will tell you is that little dotted white line that I described in the last slide that allows the regulatory parts of the brain to talk to the emotion reward parts of the brain, that white line is not mature, meaning the efficiency of those systems, even if they can reason and talk through things in a cold living room situation or dining room table situation, what's necessary in a heated emotional situation is for that to happen fast. The emotion goes up, the reward is up, the brain's firing. It needs the connections that allow the part of the brain to say, hey, stop, make a good choice. The choice that maybe they know how to make at the dining room table, that connection's not mature. It doesn't mature until they're in their 20s. We know this. This is why college is also a little bit of a rough time. But it basically doesn't, when those heated emotional situations, it's a hijacking of the system. It basically says, okay, this can't happen fast enough. What I will often tell teenagers to do, what I often tell parents to do, is the best thing that you can encourage your child to do is to pause. Just for a moment. Walk away for a moment. Stop for a moment. Because what that does is it allows the inefficient brain, and maybe the part of the brain that does know the reasoning and can say, hey, this is a bad idea, I know what the consequences are. It allows that part of the brain to talk to the other part. It allows that connection that's slow and sluggish and not really well insulated to still work. That pause, just that one moment of pause, can make a big difference. Differences with and without peers. This is the other thing that I showed it. I mean, I could have brought the brain pictures and everything, but I showed the graphs. Behavior is different with peers. That's partly because it's a heated emotion. Peers almost invariably equal heated emotion during adolescence. Even if it's positive emotion does some of the same stuff that negative emotion does during adolescence. So it's because it's the reward side, both emotion. So it's just important to keep that in mind. And it results in, again, a risk for developing mood and substance use disorders. So, I'm going to keep going. There potentially is some more good news here. And I talked about it a little bit earlier. But it's basically that the environment, the behaviors, the experiences that an individual has, they set the stage for later development. So the brain is in many ways like a muscle. You use it, you strengthen it, works better. Kind of works that way. And we've had some really remarkable studies that I'm just going to touch on for a moment to show that. So the brain is sensitive to experience, and it's sensitive to all sorts of positive experiences. So that can be music, or sports and movement. It could be different languages, it could be the arts. All sorts of things we know impact how the brain functions. And this isn't unique to adolescents. This happens across the lifespan. So things like piano practice. People who practice the piano have different brains. It actually develops the brain. And so what you're seeing here, in not a very clear way, is that white matter of the brain. So again, this is the insulation, the information highway of the brain, and those couple little yellow spots that are circled, those are areas where that pathway is better, basically. And somebody who practices the piano basically has strengthened that pathway. It allows more efficient communication from the regions that that pathway connects. And you can see the graph here. So the graph that's going up basically shows that with practice, to the right, the one that's going up is the people who actually do increase their practice over time, whereas the controls are the bottom line and it's flat. So the FA, which is basically an index of that white matter in the brain, is flat for controls, and it increases as they practice for piano players. So basically highlighting, and this is in adolescents, 12 to 16-year-olds, basically here showing that in this region of the brain, the more hours they practice, the more white matter, or the more insulation those highways are going to have. More efficiency. Better. So this is a study that came out of my lab in the last couple of years. The hippocampus. The hippocampus is a part of the brain that allows us to make new memories. It is the part of the brain necessary to make a new memory. It's deep in there, that purple little structure. And what we see is that when we look at adolescents, we did a study of adolescent males. And we looked at those who exercised a lot, aerobic exercise, really rigorous running, track, those sorts of things. And we compared them to more sedentary lifestyle folks. Maybe still just as active. Maybe they were in band, maybe they did math club, things like that. So it's not a matter of they just were doing more. But those that were physically fit and active. When we look at their aerobic fitness and we look at how it relates to the size of this region that allows them to encode memories, we see that those that are more aerobically fit have a bigger hippocampus. Now, bigger doesn't always mean better, but here it actually does. It actually correlates with their memory performance. We have tasks where those that had a bigger hippocampus actually did better on memory. So again, the fact that they have been exercising, something as simple as running track, results in a different type of brain and perhaps a better functioning brain. This is that same group of individuals. We looked at how their brain functions while they were learning. And basically, it's a complicated slide, but what I want to show you is that the high active are the kids that are exercising a lot, and the LA, the low active kids, are the ones that aren't exercising. And you can see that the low active kids have a lot more lighting up. You see that? They have more orange on their brains on the right. Everybody see that? It's a little left, the other side has less. Well, the part of the brain here that we're pointing to, I'm going to go point, it's the old school style. Part of the brain that we're talking about here, this part right here, where we see a big difference, this part up here, that's the frontal part of the brain. That's the part that's developing during the adolescent years. That's the part that I said has to work really, really hard to do tasks. Well, people who are exercising don't have to work quite as hard. They're actually performing the same way on this task. So they're remembering words, but they're not having to work as hard. When they don't have to work as hard, what does that mean for that sort of vulnerability? Like how close to being tapped out they are. Maybe they have a little more reserve. Maybe they can afford a little more. So this basically gives us evidence for that, so that in those kids that are heavy exercisers, or piano playing, or whatever it might be, we see that the brain is functioning differently, and in many ways, better. So, the not so good news is also that the environment and behavior set the stage for brain development. So there's lots of behaviors and environmental things that can happen that are positive. Kids can, they can exercise. They can play piano. They can do math club, which will strengthen the very regions of the brain that do math. There's studies in adults that say that people who drive taxis have bigger parietal cortex, the part of the brain that allows them to do spatial navigation. So this is, whatever you do, you're going to strengthen the part of the brain that does that. The problem is that there's all kinds of behaviors that an adolescent can engage in that maybe aren't so good. I'm not going to spend a lot of time on those, but I am going to touch on them because I think it's important to just be aware of. One of them is alcohol. Alcohol is the most widely used substance in adolescence, and we know that Almost 50% of 12th grade seniors have used alcohol in the last 12 months, and about 30% report being drunk in the last 12 months. These are national statistics. Oregon statistics tend to actually be a little bit higher. And what we can see here is that when we look at memory, so remember I showed you that exercise helps memory, and it helps the way the brain works during memory, and it makes the hippocampus bigger and does all these things. Well, alcohol, not so much. Alcohol actually makes memory not so good. So when we took teens that had alcohol dependence and we compared them to those who didn't drink, we can see that for verbal and nonverbal information, on average, in the red, those that had consumed large quantities of alcohol in adolescence remembered about 10% less. Now you can say, oh, well, they're still getting a B. Maybe that's not so bad, but what if it's a difference between a passing and a failing grade? That 10% difference can make a difference. It may not be huge, but it can make a difference. It affects brain structure. So the front part of the brain, the part that is so very important for all of those functions that we were describing as changing during adolescence and allowing us to regulate our behavior and become mature adults, it actually changes the part of that part of the brain. It delays the maturation of the frontal lobe. So you may be doing all you can to strengthen this part of the brain, but if your kid's out there drinking on the weekends, and by the last slide said alcohol dependence, that's extremely high levels of alcohol use. Most of the work that we've done in alcohol, though, isn't on that. It's on binge drinking, the kind that we see in all adolescents. The Friday night I'm going to have 6 beers, Saturday night I might have 5, and then I'm done for the week. It's that drinking that causes this behavior, this changes in the brain. And sure enough, the hippocampus, that little red and yellow area in there, is smaller in kids that drink. So it's bigger if you exercise. Alcohol does not do that for you. The white matter of the brain, so again, the information highway, the way that it's insulated, the way that it functions and allows areas of the brain to communicate, that actually is impacted, bless you, in people who drink as well. So the more that they drink, so the peak blood alcohol level in the last 3 months results in less sort of insulation to that highway, less efficient brain. So again, it's making the part of the brain that does the regulating not work as, it's not working as well. It's making the connections that let the part of the brain that does regulating, making them not as efficient. You can see where this is going in terms of the vulnerability I was describing earlier. Marijuana is the second most commonly used substance in adolescents. We've done studies looking at kids even after they've been abstinent for an entire month. Incidentally, in Portland, the rate of marijuana use, I would say, is almost comparable to alcohol. It's Portland and then we haven't seen any statistics yet since the legalization of marijuana in Washington, but I would gather that those rates are just going to go up. These teens show impairments after a month of abstinence. They show problems with attention, memory, executive functioning, which are all those functions that I described that the front part of the brain does, problem solving, reasoning, regulation, all those sorts of things. So again, the point being that there are all sorts of decisions and all sorts of experiences that an individual as an adolescent might come into contact with. Some very good, some not so much. So, the adolescent brain, if you didn't already think so, hopefully you now do, is still developing. It's developing in all sorts of ways, structurally, functionally, the way that the connections are being laid down and the way that they're being strengthened. And while there are many positive changes there that are occurring, so again, they're getting better at so many things, the brain's getting more efficient, it's not happening at the same time as some of the other changes. Again, that reward, that emotion stuff that's going on in the brain. And again, while many of the behaviors may positively impact them, so maybe making a decision, we didn't talk about it too much, but we talked about kids sitting at the kitchen table and telling you what they should do in a given situation. How simple a lot of kids can do that. They can tell you right from wrong, they can tell you what they do, how they strategize, the planning that they use. Those are good things. What that's doing is strengthening the part of the brain that allows them to do that. Putting them in a situation where they actually can do that with that pause strengthens the connection that lets them regulate the emotion. So the key here, and another take-home message, if you will, It's not to prevent your kids from being in any situation where Joe's sitting in his car next to, or the seat next to him and they have a yellow light in front of them. You don't, by preventing your child from ever having that scenario happen, there's no strengthening happening there. They have to be in those situations in a careful, graduated way for those connections to mature, for the muscle to get stronger, if you will. It's all about doing that in a very careful, controlled way that makes the difference. And last but not least, I always have to give a plug. Has anybody here ever had one of their kids in one of my studies? Has anybody got a mail? Oh, you have. Has anybody got a mailing to their house? Seem familiar to anybody? Surprising to me, since we mail to the entire broader 20-mile radius of Portland. At any rate, if any of you have an adolescent between the ages of, we'll conceptualize it right now as 12 to 21, we have studies going on all the way up to that age range, who want to be a part of one of our studies and to contribute to this knowledge base, to contribute to what we're learning about the brain, feel free to call the number. My lab, again, we study the healthy adolescent brain. We study things that go right and things that go wrong, all in an effort to better inform. So, thanks so much, and I'm happy to take questions. Yes?
Electronic games, what kind of effect does this have on the adolescent brain?
That is the hands down the number one question that I get. We don't quite know yet. There are a couple of studies coming out just recently. I think I reviewed one not too long ago that certainly showed changes in the brain. It's not surprising when somebody wants to spend 20 hours a day or a week or whatever it is doing something, it's going to impact the brain. We don't have enough, there's not enough research to say definitively what it's doing over the course of development. My hunch, if I were to think about what those types of games do, is that they're going to strengthen connections that allow somebody to have visual spatial problem solving, kind of planning. Some of those things will be strengthened, and those kids will do better on tasks that generalize to that. Will it strengthen their ability to interact with somebody using language? Probably not. Will it strengthen their ability that they would have otherwise gained by exercising? No. So it's a trade-off. There are going to be things that are going to be positives, and there are going to be things that are going to be negatives. Where it gets a little dicey, and again, there's no real evidence to suggest this yet, but if we think of the brain as an experience-dependent organ, where it gets a little dicey is with violence. So games that have violence. So the brain has this fancy way of habituating to things. All of us know this because as adults, it's kind of what you almost have done surpassing adolescence. You kind of get used to some of the stressors perhaps. Your brain gets better able at kind of realizing it's not quite as salient. It's not quite as novel. Well, with violent games, your brain does that in a way that's probably not adaptive. We don't want people to think that murder is normal. That's not something we want to breed as a normal thought, or that violence is a normal thing. So I really think that there's probably some negative consequences there as well, in terms of how the brain responds to negative emotion. So, other questions? Yes?
This is a really dumb question because I don't really understand how the questions work. But a connection you build for music, is it just for music, or does it relate to other types of learning?
It'll relate to other things. So those pathways are not just specific to music. Those pathways they carry information that, say, is visual spatial or motor information with planning information. So when you strengthen that pathway, it's not just when you sit down to play a concerto. You're gonna strengthen it in general anytime you need to use, say, processing of visual information to do a motor response. Does that make sense? So it generalizes. Yes?
So, sleep. You hear that teens, there's medical evidence to suggest they actually need more. It's not just that they're being lazy. And so my question is, do you know, first of all, if that's true? Secondly, is that being driven by brain development or more like the hormonal changes and the physical changes?
So the patterns of sleep are actually different. The sleep architecture, so what happens in terms of what the sleep looks like in the brain, is different during adolescence. And yes, it is in fact true that adolescents need more sleep. The biological basis of that I would be guessing at. I'm sure there's evidence out there, but they in fact do need more sleep. And what is really disheartening is it's actually the time of life where they tend to get the least amount of sleep. Again, because of pure demands, homework demands, life demands, they're staying up later, they're stressed out, they're doing homework, or they're talking, or they're texting, or they're doing whatever it is well into the late hours, and they're not getting enough sleep. School starts really early. So yes, they need more sleep. No, they don't get enough, and partly that's a function of the demands that are placed on them. Yes?
Would it be a good source of information to be on early more about the hippocampus that has been ranges, nutrition, and be useful to sort of learn about it?
So there is, I should have looked this up for you guys. So the Oregon Public Health, the Oregon Public Health Association perhaps has a good website that has some information about teen brain development. The National Institutes of Health, depending on what issue you're interested in, if you go on the National Institutes of Mental Health, you can hear a little bit about the adolescent brain and how it relates to the development of mental health disorders. The National Institute of Alcohol and Alcohol Abuse will tell you a little bit more about adolescent brain development as it relates to alcohol use. National Institutes of Health is probably a good way to go. It's nih.gov. Other questions? Yes?
So when a child is assessed and determined to have certain deficits, there's a lot out there, a lot of programs that is now to do with the sort of brain balancing, like brain surgery. Some of those programs are short and intense, say 6 months. I guess my general question is, once you build new connections, they're permanent, right?
Not necessarily.
So how does that work? I'm thinking of a program of 6 months.
So, and again, this is part of this is anecdotal because it depends on whether there's some good evidence behind the program. I'll tell you just kind of at face value, there are lots of programs out there that have absolutely no empirical evidence behind them. Certainly the brain does change the function of experience. But typically, in order to have sustained change, both positive and negative for the most part, it needs to be sustained activity. So when we do a program that allows the brain to, say, integrate right and left better, or we do a program that's going to teach somebody to do divided attention better, because we all can do that better, a little multitasking. The idea is that function that they're learning needs to generalize and continue to be used. So you may change the brain. You can change the brain temporarily, or you can change it in a way that seems more robust at first and then maybe diminishes, if that makes any sense. And there's evidence to suggest that a lot of programs that build, say, working memory or build problem solving in the brain do result in changed behavior and changed brain functioning. How long that persists is really unknown at this point. And some of the programs that you're talking about don't have evidence behind them yet. So just use caution and know that most of the things, unless it's something detrimental, are probably going to benefit your child in some way. It's whether that's going to be a sustained benefit and whether it's worth the trade-off. Yes?
What about adolescents and texting and Facebook? Is there any evidence about that kind of communication impacting face-to-face communication?
There will be. There's not yet. We all know that that's coming, right? It's just, no, it's the same thing. It's double-edged, right? There's going to be things that they're better at. I mean, I know many adolescents text a lot faster than I do. The dexterity of their fingers is probably far better than mine. Now, dexterity of fingers, I don't know how far that's going to take people in line versus being able to talk face to face, but I think that perhaps it will change written expression. Maybe the written expression will be somewhat better. I mean, even when they're using shorthand, they're still using written expression. So I don't know. There's no evidence yet, but certainly if we think the brain is a function of experience, there will be. Before I go on, there is one thing I will say, that the blue light that's emitted from the iPhone or the phone changes the sleep cycle. Please discourage your kids from using that an hour before bedtime. I know that's probably like asking you to make sure that your child, I don't know, it's almost impossible. But it changes, it'll delay their circadian rhythms if they can't go to sleep as well, which is just going to mess them up further. That blue light, TV, computer, phone, should probably be stopped an hour before bedtime. Those, so a Kindle or something like that, they tend to not emit the blue light, so they're not as bad. Not as bad. I don't know if they're good, but they're not as bad. You had a question too?
Yeah, I had a question. I just noticed that it seems like every other person I meet, whether their child's in college, high school, or middle school, they seem to be on Adderall. And I'm just wondering, what's with that? I don't know, have you noticed anything like that?
So, yeah, so the question was that, why is everybody on Adderall, which is the medication used to treat ADHD? Why is everybody on this medication? And I will say there's a couple reasons for that. One, the diagnosis of ADHD has increased in recent years. Now, the reason for that is somewhat unknown. There are multiple reasons. We know that there are environmental influences that increase the incidence of ADHD. So is ADHD actually going up? Yes, I actually think it is. There's genetic components to ADHD. So the more people that have ADHD, the more people are going to have ADHD if they have offspring. Our ability to diagnose and the keenness of our diagnosis has probably gone up over the past couple of decades. So kids, you'll often hear, or at least when I meet with parents, I'll say, maybe their kids coming in to be evaluated for ADHD, and I'll say, did you have ADHD? Oh, well, back then they didn't really diagnose us. I mean, there's lots of parents will often say that. Yeah, I might have, but they didn't diagnose that back then. Well, they do now, and they do it with like a real high level of scrutiny. Your kid doesn't sit still in school and all of a sudden they're getting evaluated for ADHD. So it's a high level of scrutiny and diagnosis. It is increasing. It's increasing due to genetics and to environmental influences. And the reason that kids are on ADHD medications, such as Adderall, is they actually are effective. They're effective. In fact, aside from a small percentage of the population, if I handed Adderall to any of you, you'd probably be able to pay attention better. It helps most people. With these few exceptions. There are a few that it does not help. But in general, it helps. And in fact, the research suggests that in an individual that actually has ADHD, and you treat them with a traditional stimulant medication, we may, in fact, be able to correct the pattern of their brain development. So maybe they were having brain development that was off track, and you put them on medication, and they look more like somebody who doesn't have ADHD after time. So medications are not all bad. They actually can potentially correct the course of development in an individual who actually has ADHD. So it's a long answer to your question, but I thought I'd elaborate a little bit. Yes?
Well, kind of continuing with this question of ADHD, attention deficit disorder, I also see that we see a lot of people who diagnose with this condition. And I want to ask you a question about information overload. It seems like children, adolescents, they receive a lot of information from different sources, like much more information than maybe we receive when we were growing up. So how this information overload can increase development? Any of the condition is attention deficit disorder. That it's too much information going on in your brain that, like, they say, that's too much. I cannot pay attention anymore because this is too much.
Well, did people hear the question, or should I repeat it?
Could you repeat it, please?
What? Repeat it? So the question was, with regard to ADHD or just inability to attend in general, how much does information overload play a role? So clearly our youth today are exposed to way more information than we were. I mean, I used to have to go dig out an encyclopedia to find out anything. It's just so different now, really. I think that the brain has a capacity. We all have a capacity, right? And our capacity varies. Our capacity to hold information, our capacity to process information, there's a wide range of variability. And the capacity to do that during adolescence is increasing, but it's also variable. I don't have a scientific answer for your question in terms of how information overload is impacting the brain or attention deficit disorder. But what I will say is that if we think about it again as sort of a vulnerable system or a taxed system, too much is going to tip the scales. It's that idea, right? It's the 7-year-old with 100 pounds. It's, okay, I'm at maximum capacity, just a little bit more, it's going to tip it over. So that's the way you conceptualize it. Everybody's attention system breaks down when we have too much. Everybody's attention system breaks down when you've got something emotional on your mind. This is another analogy that I give parents all the time. If you have a child who, whether it's or I should say an adolescent, who whether it's because they fell down in the lunchroom and everybody stared at them and laughed at them and they're having a really rough day, so they're having some mood issues on that, or maybe they have something more significant, maybe they have a more persistent mood disorder. What happens then is that they only have one brain. And if the resources of their brain are being drawn into some emotional state, whether it's anxiety or depression or just humiliation from falling down in the lunchroom, what that does is takes away the resources that are left to extend to the rest of the external environment. So you'll see little blips in their attention. It breaks down. It's a vulnerable system. It's taxed. Adolescence is a time of sort of heightened taxing of that system. So that's the answer that I would give you about that. Other questions? So we'll start in the back, because I think she raised her hand first. Blue sweatshirt, you, yes. And then I'll come to you.
How do you untax them when they become overtaxed? What are ways to, when they're totally on an emotional high?
I think that's a very good question, and it's a challenge that everybody who's a parent is faced with. Sort of how to selectively take some things off the plate.
Running out of my house screaming probably isn't a good way.
Yeah, there are worse things. I think that it is your job as a parent and as an educator to make strategic decisions about what is going to go on your child's plate and with them, to help them see sort of, okay, maybe we're doing soccer and we're doing, some other kind of club, and then you've got this huge course load, and maybe you're studying for the SATs. Okay, we're going to start, maybe they want to add something else. Maybe if you're feeling like they're at their max. Many teens are not responsive to the word no, and they want to be able to see for themselves. So I think one of the challenges is sort of strategically showing or trying out that scale or that load, basically, and seeing how close to max it is. Sadly, we don't often know how close you are to maximum until you tip it. We don't really know where anybody's maximum is until it goes to the test. And so sometimes you have to play with that a little bit and allow them to have some say in playing with that. Like, what is going to be the threshold? What's going to tell me when enough is too much, when enough is enough, or too much? What is the measurement of that? How are we going to check in? Is homework going to be getting done? How's your emotional state? Okay, we'll add a little bit more on. What's the evidence here? How are we handling this? I mean, it's good to have sort of those checks and balances explicitly stated. How are we going to know that we haven't tipped the scales? If that makes any sense. And doing that in a graduated way, starting early and young, where you can kind of layer it on and watch that happen. That's a variable process too. Your kid in 10th grade is not the same as your kid in 12th grade, and they may be able to handle more or less things depending upon what else is going on. It may vary by week, which is the really frustrating thing. So it's a matter of just playing that game, taking things off, helping them take things off, helping them to communicate when enough is too much, watching the signs of that happening. It's not the best answer. There's not really any magic one on that one. Sorry. You had a question too.
Yeah, getting back to the ADHD question with Adderall, I read an article in the paper this weekend about how boys are more likely to be diagnosed with it because they can't sit still in class, so they're more likely to act out, and so it becomes more evident, perhaps to a teacher, to bring up the possibility that there's ADHD and they should be tested. But a lot of girls go undiagnosed because they can sit still and behave better, because that was obvious. And so that as they go into adulthood, they haven't been treated for that, and perhaps by treating them later in life, they can still correct their behavior so they can be more productive. Do you find that true with that at all, or does it really need to be dealt with when they're children and developing?
There's no evidence yet looking at sort of late life treatment versus early life treatment and how, you'd have to follow somebody and have kind of a controlled trial where you watch them over a really long period of time. So we haven't done that yet. Certainly the medications help in adulthood, and you're very correct in the fact that boys tend to be diagnosed with a combined type of ADHD, which has the hyperactive component, and that's more disruptive and positive and gets called out by teachers. typically to make the diagnosis, the symptoms need to be present in more than one environment. So school's where our kids are, and not at home most of the time. And so school has to report some symptoms. The girls that are inattentive and more daydreamy, who don't have the hyperactive or the impulsive symptoms, do tend to go undiagnosed. Both types of symptoms, there's some emerging evidence that with or without treatment, because the brain is developing and the regulatory capacity of the brain is developing, you'll hear stuff about people growing out of ADHD. And again, we haven't followed kids long enough to really know if that's in fact the case, but there's at least some emerging evidence to suggest that for some folks that is the case. So a girl who had undiagnosed attention problems in class very well may either learn to compensate, and most likely that's what's happening, they're learning to compensate and they no longer exhibit symptoms in adulthood. So it's a complicated question and we just don't have the years of research behind it to know a definitive answer. Yes?
You mentioned about music and exercise that What about food?
Food? Oh yes. Food affects the brain as well. You know, we think about fetal nutrition, things like that when you're pregnant and you're taking your folic acid and eating your fatty acids and all sorts of things like that. I mean, the brain will continue to develop as a function of the good resources that we provide it. So there's certainly evidence to suggest, I mean, this is less related to the specific foods. I don't know all the dietary literature, but there's even some research coming out of my lab that would suggest that when we look at kids that have obesity, now obesity isn't always secondary to poor dietary choice, but when we look at adolescent obesity, we see that they're performing more poorly on tests of cognition. So tests of memory, tests of attention. If we compare obese adolescents to healthy weight adolescents, we see changes in their cognitive functioning. And we're in the process of looking at how their brains differ too. So again, I can't speak to all of the unhealthy food choices that an adolescent might make, but we certainly know that if they are excessive to the point of causing obesity, that it can cause some pretty significant damage to their brain. Other questions? Yes?
You mentioned the early onset of puberty in Western countries. And, you know, we've heard dietary, hormones in the milk, blah, blah, blah. Is there any real evidence to suggest where that's coming from and how we could normalize it, or is that just evolutionary?
I think it's evolutionary in some ways. I mean, it is specific to our culture in that we do have a high-fat diet. Body mass indexes tend to be higher. So the hormones that are some of the growth hormones that come on early to start the cascade of puberty tend to do that sooner. I don't know, I can't cite the literature for you on exactly why that is, but in Western cultures, I think there is a huge dietary component and there's a huge sort of evolutionary component as we continue to give birth and procreate that perpetuates that cycle. Other questions? Yes?
Is there any evidence that maybe there's like more stress on teenagers now than ever, and that there's a correlation between that and maybe poor mental health or increasing stress?
There is evidence about stress, and I believe, Grace, you can correct me, but one of the graduate students from my lab who's now a postdoc is going to be coming to do a talk. I think she's talking about stress.
That's right, February 11th.
Yes, so she will be talking about some of this that you'll hear, if you come to that, you'll hear some of the very same things that I described, but with a real focus on adolescent stress and what that does to the brain and what we know about adolescent stress versus other types of life stress. So, yes, it does have an influence, but I don't want to tell you all of it because then you would come to her talk.
Just out of curiosity, how do you define that stress? Because when I look at the kids, they seem to have such a booked schedule. They do the sports, they do the music. It's almost as a constant demand on their body and their mind.
So I think there's...
Is that the stress?
Well, that's not how we typically conceptualize stress. Stress is typically, we tend to measure it in some emotional kind of response or in some kind of an event-related response. So the measures that we would often give in laboratory settings are a cumulative amount of stressful events. And who are we to decide what's stressful? Maybe the fact that they're carrying, that many courses and sports is very stressful. And perhaps we don't tap into it as well at that end of the stress spectrum. When we think about more significant emotional stresses, post-traumatic stress, traumas, we definitely have a better handle on how that is impacting the brain, but you're right. I don't, there's so much variability in both how one interprets stress as well as what causes stress for a given individual. I don't think we have a good handle on some of the very normative things that you're describing. Other questions?
Okay.
Thank you.